Hi everyone, this is Radha as usual. I'll be presenting my PPT on Affinity Propagation. It is a case study algorithm. The name depicts like affinity is nothing but a similarity, and propagation is nothing but transmission of light, sound. So here the transmission of message is happening inside the algorithm. So based on the similarity, the clusters are identified, and based on the transmission of the messages, exemplars are identified. So this is the gist of the affinity propagation algorithm. So here we have a picture of affinity propagation algorithm. Once the clusters are formed, we implement them in Python. So affinity propagation is a clustering method and it groups similar data points into one cluster. And it allows the data points to communicate with each other by exchanging messages. So these messages help them to select the leader, which is nothing but exemplars. So it's like we group fruits in similar categories, such as we grouping apple with apple, banana with banana, mango with mango. So how we group based on their similarity, size, shape, or color. So like this, clusters are formed based on their similarity in affinity propagation algorithm. So there is algorithm steps followed in the algorithm. Like initially, data point I will send the responsibilities to candidate exemplar K. Exemplar is nothing but leader K, telling that I would like you to be our leader. These are the responsibilities, and I will like you to be our leader. So then the candidate K, exemplar K, leader K, will reply back to data point I like, okay, I am available. I will be your leader. I prefer to be a leader. So that is what responsibilities and availabilities are. So a similarity matrix is nothing but it's like a scorecard, like how similar each data points are. So based on the similarity, the score will increase. Higher the similarities, higher the score. And preference, how much a data point want to be a leader, exemplar. So the preference value might change. Like initially, all will have the same preference value. Based on the exemplar, the preference value may change. Damping factor is a special trick which we use to stop the data points. Like there may be a data points who have a wavering mind. Like first they select K, then the next one they select K1. Like that they are wavering in their leader selection. So we don't want this to happen. So we use a damping factor to stop them getting too excited and changing their minds quickly about who should be their leader. Responsibility. So already we have discussed this. So each point will send responsibility, suggesting how the other point is suitable to be their leader. Now availability is nothing but the leader will reply back to the data point like, okay, I will be your leader. I can be your leader, like that. So that message is something your availability. So based on the responsibilities and availabilities to and fro, based on the messages passing from data point to the exemplar and exemplar to data point, exemplars are getting selected, are getting finalized. The leaders are getting finalized here. So when the message won't change much from one round to the next round, then that time they know that data points have made up their mind and the exemplars are finalized. So once the exemplars are finalized, those exemplars will form the center of the cluster and the data points who supports them will be around them. So that is the time when the algorithm has converged. So pros and cons, advantages of this algorithm is we don't need to redefine the cluster. We don't need to mention the cluster, number of the cluster as the cluster is forming automatically based on the exemplar selection, and they can handle various types, cluster types and various cluster size and shapes, and the exemplars are the centers, and they are suitable for complex data sets. Limitation is that as we have a process like sending messages and leaders are selected and then cluster is formed, This process might take time. So it can occupy the memory, so it is computationally expensive. They might be sensitive to parameters like damping factor, and exemplar selections might go wrong. So because of that, they may be sensitive to parameter, and the clustering might be misclassified. Convergence issues. So some data points may not make up their mind, and they may be either like as I select leader 1 and then leader 2. So this may lead to convergence issue. Thank you.